Hello, today we are talking about our paper, Prostate Cancer Management with Lifestyle Intervention from Knowledge Graph to Chatbot. Here is the basic process flow. First, we have the ontology, then we have the data collection from which we make the knowledge base. After that, we do the knowledge graph extraction. Then we have different XAI or X models, resulting in the bots, which finally leads to the application. When we train AI models with a lot of parameters to which we apply transformation, we end up turning the entire process of pre-processing and model building into a black box model, which is very hard to interpret. However, in the medical domain, understanding applied model are essential, in particular when informing clinical decision support. With the onset of explainable AI, the user should trust the system and understand the prediction comes with a justification. Using an established and well-received KG for AI-based clinical prediction is a step forward in this direction. PCLION integrate 397 lifestyle and lifestyle-related factors associated with the PCA and is the first of its kind for a specific disease. It contains 320 attribute annotation and 11 object attributes. The logical relationships and completeness meet the ontology requirements. This was the first lifestyle ontology for cancer, which is perfect building block for our database. Now we have PCA LISTDB. This is the first database which focuses on specific disease-related lifestyle. It integrates possible lifestyle and lifestyle-related factor together with the corresponding diseases or drugs. It provides a lifestyle-wide association study of PCA, seeking to identify the systematic and deep-seated studies between lifestyle and the PC. In this paper, we take advantage and accuracy and standardization of the PCA LISTDB to build our knowledge graph on this new 4G platform. The resulting knowledge graph consists of more than 25,000 entities and 66,000 relationships. This is the basic architecture of the system. From PCA-LISTDB, we take the different SQL file and then convert it to the JSON format so that our system can understand it. After that, we perform the entity and relationship extraction on the resultant JSON files. Here we identify nodes and create relationships. Later we feed these nodes and relationships to Neo4j server. We have 11 types of entities in our knowledge graph as shown in the table and 14 types of relationship between these entities. Here is the snippet of the knowledge graph. Here it is showing the outcome of PCAs caused by genistein and milk. Here we try to show how the system works. When the user inputs a query in the input box, the relevant lifestyles are displayed in the drop-down box for the selection. Since the system uses fuzzy search, the user does not need to input the full and precise lifestyle name to get the desired result. As with the input of each word, the drop-down list will give the nearest suggestion. With the click of the submit button, the query is executed. This request is then transferred to the Neo4j server through the RESTful APIs. Based on these post requests, the Neo4j execute the query command. Here the template first filter out the outcome of several PCAs caused by the requested lifestyle. Thereafter it selects nodes that are directly connected to the central node. Finally, the resulting nodes are combined for display. The resulting data is returned to the front end in both visually and JSON format. This is the basic idea of the dialog system utilized. The user asks a question, and if the entities are present in our KG, the system proceeds further. We start with n-gram split of the questions to generate the tokens. Later we recognize entities and extract relationships from these tokens along with the type of the question. This is used to make the query template, which is sent to the Neo4j server for the answer generation. The final answer is shown to the user via intuitive UI interface. This is the UI of the chatbot based on our knowledge graph. Both the knowledge graph and the chatbot system are live and running. This code is also available on the GitHub. Thanks.